Hello guys, so we want to start lecture 5. In this lecture, we want to talk about finding Laplace transform using graph of a function. So in this lecture, I just solve one example. The example that you want to solve is find the Laplace transform of this function ft. So we have graph of ft from 0 to 1 is equal to 0, and then we know that the graph passes from point 1 and 0 and 2 and 2. So in order to find Laplace transform of this function, what we have to do, we have to use definition of Laplace transform. So in fact, we have Laplace transform of ft. It's equal to the integral from 0 to infinity e to the power of minus st times ft times dt. So what's ft? We have just one graph. We don't know the equation of ft. So as a result, I try to find equation of ft. So ft has two equations when we are in this range from t equal to 0 to 1. So when t is between 1 and 0, so ft is equal to 0. So you can see that here ft is equal to 0. And after that, from this point 1 and 0 to 2 and 2, so you have another equation. So I think you remember when you have 2 points on one line, like x1, y1, and x2, y2. So when you have 2 points on the line, you can easily find equation of the line. So remember that the equation is equal to y minus y1. It's equal to y2 minus y1 x2 over x1 times x minus x1. So in this case, we have one point which is 1 and 0, and we have one point which is 2 and 2. As a result, for our case, so y, which is ft, minus y1. y1 is what? y1 here, you can see it's equal to 0. It's equal to y2 is 2 minus y1 is 0 divided by x2 is 2 minus x1 is 1 times, so here variable is not x, it's t. As a result, we have t minus t1. So t1 is 1. So we can say that ft is equal to 2 times t minus 1. As a result, we could find this equation as well. So it's 2t minus 1 for t greater than or equal to 0. So now we have equation of ft. We can easily apply Laplace transform. But you know what we have here? What we have here is that the equation of ft when t is between 0 to 1 is different from equation when t is greater than, oh sorry, here I made a mistake, so it's t greater than 1. Greater than 1. So now let's take the integral. So Laplace transform of ft, it's equal to, based on the definition that we had, it is the integral from 0 to infinity e to the power of minus st ft dt. The equation of ft in these two subintervals, they are different. As a result, I split the integral in two subintervals. The first integral is from 0 to 1 because we have one equation, plus the second integral is from 1 to infinity because we have the second equation. From 0 to 1, ft is equal to 0, so we have 0 times e to the power of minus st dt. And from 1 to infinity, we have e to the power of minus st times ft. Ft is 2 times t minus 1 dt. So 0 times e to the power of minus st is 0. As a result, this integral is equal to 0. So Laplace transform of ft is equal to 1 to infinity e to the power of minus st times t minus 1 dt. So I just put 2 out of integral. So now we have to just find this integral, the integral of e to the power of minus st t minus 1 from 1 to infinity. So I assume that t minus 1 is u, and as a result dt is equal to du. Assume that e to the power of minus st dt is dv. As a result, v is equal to minus 1 over s e to the power of minus st. So Laplace transform of f t is equal to 2 times, because we have a 2 here, u times v. So u is t minus 1. V is minus 1 over s e to the power of minus st. So limit of integral from 1 to infinity minus integral of v du. So v is minus 1 over s e to the power of minus st. The integral is from 1 to infinity. V and du, so we have it here, is equal to dt. It's equal. Now I want to find, oh, here we have minus 2 as well, because at this point we had 2. So now we want to find this part, t minus 1 times minus 1 over s e to the power of minus st. When t approach infinity, so we have t minus 1, so it's infinity, e to the power of minus infinity. So we have to find this term. So let's say we say note limit of 2 t minus 1 times minus 1 over s e to the power of minus st when t approaches infinity. So I can just simplify it. We have 2 times t minus 1 over minus s e to the power of st when t approaches infinity. So in the past we saw that when we have this limit, so we have to use L'Hopital rule. Derivative of numerator is 1, derivative of denominator is, so let's find it. So here is 2 times 1, so it's derivative, and here we have minus s squared e to the power of st when t approaches infinity. So it's based on L'Hopital rule. So as a result, this term is equal to 0. So when we apply the upper limit is equal to 0, when we apply lower limit, so we have t minus 1, so 1 minus 1 is equal to 0. As a result, this term is equal to 0. It means that Laplace transform of ft is equal to, so minus 2 times minus, so it's plus 2 over s integral from 1 to infinity e to the power of minus st dt. So we have 2 over s, so the integral of e to the power of minus st is equal to minus 1 over s e to the power of minus st. The integral from 1 to infinity. When t approaches infinity, it's 0. When t approaches 1, so we have e to the power of minus s. As a result, this term is equal to 1 over s, and 2 over s times 1 over s. Oh, it's 1 over s e to the power of minus s. So we have 2s squared e to the power of minus s. So we could find integral of this function.